Hello everyone, welcome to our channel. Now I am here with the new topic, estimation of hardness of water by complexometric method using EDTA. Estimation of hardness of water. This analysis is done by complexometric titration using standard EDTA and EBT as an indicator. In this analysis, you have to write the structure of EDTA, you have to write the principle, procedure and calculation. EDTA, ethylene diamine tetraacetic acid. See here structure, CH2 single bond CH2 and single bond nitrogen and nitrogen. Here write 4 acetic acid structures, CH2COOH, CH2COOH, CH2COOH and CH2COOH. This is the structure of EDTA. In this structure, 2 nitrogen atoms are there, 4 acetic acid groups and ethylene bridge between 2 nitrogen atoms. E is ethylene, CH2CH2, diamine, 2 nitrogens are there. Tetra means 4, acetic acid, 4 acetic acid groups are there. 1, 2, 3, 4. And this is disodium salt of EDTA. In this analysis, we are going to use disodium salt of EDTA. And coming to principle, in this complexometric titration, the water sample is titrated with standard solution of sodium EDTA and using EBT indicator. And we know that hard water contains calcium and magnesium salt. Here I am simply writing calcium and magnesium as M. M means metal. And now observe reactions I am going to write here. Here EBT indicator, erythrome black tea indicator. When EBT indicator added to the hard water, it reacts with whatever the metal ions present in the hard water, like calcium and magnesium, and it forms as metallic EBT complex. This complex color is wine red color and it is unstable complex. Now this complex is titrated with EDTA. Metallic EBT reacts with the EDTA and forms metallic EDTA complex and it gives free EBT. The color of free EBT is blue color. We can call clear blue or steel blue color. Metallic EDTA complex is stable complex. In this titration, we need to use buffer solution. The purpose of buffer solution, it maintains pH neutrality. We should maintain pH about 9 to 10. Again, see the principle. When EBT indicator added to the water, it reacts with the metal ions present in the water and forms as wine red color due to formation of metallic EBT complex, and then it titrated against EDTA, it forms as metallic EDTA and it gives free EBT. And color of the solution is blue color. In this titration, first solution turns into wine red color due to formation of metallic EBT complex, and then it turns into blue color due to formation of free EBT and metallic EDTA complex. Metallic EDTA complex is colorless complex. Coming to procedure. In the procedure, there are 4 steps are there. First one, preparation of standard hard water. Second, standardization of EDTA solution. Third, titration of unknown water sample. Fourth, titration of permanent hard water. Let us see first one, preparation of standard hard water. Take 1 gram of dry calcium carbonate in a small beaker. Then dissolve it with little amount of dilute hydrochloric acid. Then keep on water bath about 10 to 15 minutes to evaporate HCl. Then dissolve this content with a little amount of distilled water. Then transfer into a 1 liter of distilled water. Now this solution is called as standard hard water. Second step, standardization of EDTA. Take 20 ml of standard hard water in a clean conical flask. This standard hard water should be taken from 1 liter of standard hard water already we prepared in the previous step. Then add 2 to 3 drops of EBT indicator and add 2 to 5 ml of buffer solution. Now solution turns into wine red color. Now titrate this solution with EDTA solution till wine red color changes to clear blue color. If complete solution turns into blue color, then stop the burette, note down the burette reading as XML. Now step 3, titration of unknown water or titration of unknown hard water. Take 20 ml of sample water into a clean conical flask. Then add 2 to 3 drops of EBT indicator. Add 2 to 5 ml of buffer solution. Now solution turns into wine red color. Now titrate the solution with EDTA solution taken in a burette till wine red color changes to clear blue color. If complete solution turns into blue, then stop the burette, take the burette reading as YML. Now step 4. Titration of permanent hard water. Here you have to take 20 ml of permanent hard water. I will explain how to prepare permanent hard water at the end of the procedure. Now take 20 ml of permanent hard water in a clean conical flask. Then add 2 to 3 drops of EBT indicator. Then add 2 to 5 ml of buffer. Now solution turns into wine red color. Now titrate the solution against EDTA till color changes from wine red to blue. Now stop the burette, take the burette reading as ZML. Observe this procedure except first step, second step, third step, fourth steps. These 3 steps are similar steps. Only one variation, that is water. In the second step, we have taken 20 ml of standard hard water. In the third step, we have taken 20 ml of sample water. In the fourth step, we have taken 20 ml of permanent hard water. Remaining steps are same. Addition of EBT and buffer solution. Solution turns into wine red color. Then titrated against EDTA. Now solution turns into blue color. All steps are similar steps. Coming to burette reading. For second step XML. For third step YML. And for fourth step ZML. Now I will explain preparation of permanent hard water. Take 100 ml of sample water in a beaker and boil it for 10 to 15 minutes. During boiling process, evaporation takes place. The concentration of hardness producing salts present in the water will be increases. Now temporary hardness producing salts gets converted as precipitates. Then filter out this precipitate from the water. Now make up to 100 ml with the addition of distilled water. Now this water is called as permanent hard water. From this 100 ml, take 20 ml of permanent hard water. Here remember one thing. In the first step preparation of standard hard water, 1 gram calcium carbonate dissolved in 1 liter water. If 1 gram dissolved in 1 liter water, we will get concentration 0.01 m when we substitute in the molarity formula. Now calculation part. In the calculation also there are 4 steps. First one, standardization of EDTA. Second, determination of total hardness of water sample. Third, determination of permanent hardness of water sample. Fourth, determination of temporary hardness of water sample. Coming to first one, standardization of EDTA. Now write the formula, molarity formula. Molarity formula for dilution, M1V1 is equal to M2V2. Here 2 solutions are there. One is water solution, another one is EDTA. Here M1 is molarity of water sample, V1 is volume of water sample, M2 is molarity of EDTA solution, V2 is volume of EDTA solution. Now we have to determine strength of EDTA. Formula, M2 is equal to M1V1 by V2. We know that 1 gram of calcium carbonate dissolved in 1 liter water, we will get concentration 0.01 m. Here M1 is molarity of water sample. In the place of M1, substitute 0.01 into volume of water sample is 20 ml by volume of EDTA, that is XML. Because in the procedure, we have taken 20 ml of standard hard water in a conical flask and burette reading is XML. Now M2 is equal to dash M, that is the strength of EDTA. Now second step, determination of total hardness of water. Same molarity formula, M3V3 is equal to M4V4. Here M3 is molarity of water sample, V3 is volume of water sample, M4 is molarity of EDTA, V4 is volume of EDTA. Now we have to determine strength of water sample, then amount of water sample. M3 is molarity of water sample, that is equal to M4V4 by V3. So M3 is equal to M4 is molarity of EDTA. We know that M2 also molarity of EDTA. So instead of writing M4, I am going to write M2 because M2 is equal to M4. V4 is volume of EDTA, that is YML, by V3 is volume of water sample, that is 20 ml, that is M3 is equal to dash M. Formula, therefore total hardness of water sample is equal to M3 into 100 into 1000. Then we will get total hardness of water sample. Here 100 is molecular weight of calcium carbonate, 1000 is for 1 liter. Now step 3, determination of permanent hardness of water sample. Same formula, M5V5 is equal to M6V6. Here M5 is molarity of water, V5 is volume of water, M6 is molarity of EDTA, V6 is volume of EDTA. We have to determine permanent hard water concentration and hardness. So formula is M5 is equal to M6V6 by V5. Here M6 is molarity of EDTA. We know that M2 also molarity of EDTA. Instead of writing M6, here also I am going to write M2. Into V6 is volume of EDTA, that is ZML Bureau reading, by V5 is volume of water sample, that is 20 ml. Your formula M5 is dash M. Therefore, permanent hardness of water is equal to M5 into 100 into 1000. So we will get permanent hardness of water. And last step, determination of temporary hardness of water. And we know that total hardness is equal to temporary hardness and permanent hardness. We want only temporary hardness. Then subtract permanent hardness from total hardness. Then formula, temporary hardness is equal to total hardness minus permanent hardness. We will get temporary hardness and write the units ppm or milligrams per liter. When we observe formulas, all formulas are simple formulas. For first step, M1V1 is equal to M2V2. For second step, M3V3 is equal to M4V4. For third step, M5V5 is equal to M6V6. In the first step, we have to determine concentration of EDTA. In the second and third step, we have to determine concentration of water. And to convert concentration into amount, multiply with 100 into 1000. And temporary hardness is very simple. Example, if we get 500 ppm is total hardness, 300 ppm is permanent hardness. If we require temporary hardness, then 500 minus 300, that is equal to 200 ppm. 200 is temporary hardness of water. Thanks for watching. Subscribe for more videos.